This video is about how to figure out how much water you saved with your school water audit once you have completed your faucet audit. So Amber will come out to your classroom and she will do the flow rate investigation with your students and change out all the aerators of the school. And then you need to take that data and make it into something that you can use to figure out how much water you save. And so you have this really handy Excel spreadsheet, and I'm just going to show it to you what it looks like blank first, and then we'll look at a school's data so you can understand what you're looking at. The first thing that you're going to have is the faucet flow rate data, and this is what we will have collected on the school water audit day. And so this information will be stuff the students have collected and are very familiar with, and hopefully we can enter it as they come back from auditing faucets during the day or off of their worksheets that they've turned in at the end of that day. Then the next thing that you're going to have is this frequency and duration data sheet. The thing to know about this while it's blank is that you can use either these two charts here to calculate your frequency and duration, or you can just enter them manually by, overwriting that equation and just putting the number in. So we'll talk about how to collect those in a minute, but that data is there. And then once you have entered that data, there's two more yellow boxes you need to fill in. One is the number of students in your school, number of people in your school, assuming all people wash hands, not just students, and the number of school days that you are at school. We only want to count water savings and how much we're washing our hands when we're actually on campus. And then the rest of the data sheet will auto calculate. So it's going to go through and give you the calculations for how much water you've saved and construct graphs so you guys can see what you've saved and then make that into something that makes sense for your students and they can see it visually. All right, so now we're going to look at the data from Doolin Middle School. So this is data that you'll get. Amber will help you enter in on the day of your water audit. And you'll see that there's a baseline flow rate. So that's what the condition is when the students start the project. And then there's a without the flow rate project. And it looks like here, without baseline, without, we're just going to do one time and then a new aerator. The without is not important for our calculations. It doesn't help us know how much water we save, but it's a cool thing for the kids to see. So
if I can chime in on that one really quick, can you scroll back up? So the baseline average flow rate is no aerator. And then, that's with an aerator. And then the without aerator average flow rate is the second column.
Correct. Did I say it wrong? Yeah. So the baseline flow rate is what you have when you show up at the faucet. There's probably an aerator on it, and its efficiency is hopefully lower than what we're going to put on. So that's the starting point. And then the without an aerator is something we try out in the middle so students get a sense of what aerators do. And then the new aerator is going to be what results in our savings.
All right, good clarification.
All right, so once the students have collected this, they've done a big project and they feel like they're done, and you're going to ask them the question the next day, hey guys, how much water did we save? And this is the numbers that they have. These are the averages and change in flow rate. So remember that this is the baseline and this is with the new aerator. So you can imagine, Amber, what do you think students will come up with from this if you say how much water did we save?
Well, they might say some of those numbers down there. So they might say we saved 0.48 gallons per minute of water.
Something like that, right? They might say any number of things. So we want to help them to think about, well, what does that mean? And do they remember the units? It's gallons per minute. And so if it's per minute and we want to know how many gallons we saved, we need to figure out how many minutes the faucets are on. Hopefully students can think that through themselves. And so I would really invite you to have them pair share and think and really wrestle with this problem, because they can come up with it. It's just going to take some thinking, right? And
right,
so
because typically students wash their hands 20 seconds. So then we have to figure out, well, how many minutes is that?
Right.
So that's something we might want to throw that in there.
Right. So we might want to have them think about, okay, if they want to know how many minutes the faucet is running, how are they going to figure that out? And they might come up with some wild ideas, which I love, like let's stand by the faucet and measure all day long. And let's measure, and then you can carry that out. Okay, well, how will we do that for every single faucet on campus? Like, are you guys going to stand at the faucets all day long for a week? Or like, how are we going to make this happen? So that you can get to the idea of a representative sample. And you know that we're going to find an average. And so the easiest way to find an average is to think about individual people and how long they have their faucet on for themselves washing hands. So you can even think about yourself if that's helpful. And then you're going to go about collecting frequency and duration, right? How often do people wash their hands and how long do they wash their hands for? And the sky is the limit here in terms of how detailed you want to be or how simple. Let's start with frequency, which is how many times a day somebody washes their hands. So if we want to figure that out, the simplest thing would just be to ask your kids, right? They can just do a survey of themselves. How many times do I wash my hands a day? And you can figure that out. You can send them out and they can do surveys of other kids on the campus. You might want to talk about that, like are 6th graders washing their hands a different amount than 3rd graders or 10th graders? You know, we can talk about that difference too, and they can think about who they would want to survey. So they can do a number of different things. This chart is set up so that if you did it as a survey and kids went out to different classrooms and did a quick survey, they would go to the room, they would count the number of students and figure out how many times that class as a total washes their hands in a day. And then it will calculate down here the number of average, right? It'll take the number of students and the total amount of washes and divide them.
And they could do, instead of going out to classes, you could do each one of your own classes as well.
You could do each one of your own classes. I've also had teachers use Google surveys and just send them out to colleagues and have their colleagues quickly figure that out with them.
Google surveys, that's also a really good idea.
Yeah, so there's lots of different ways to do that. So that's frequency. And then duration is how long the faucet is on. You're going to remember that our Flowrate bags are calculating in minutes. So we want to make sure we record that in minutes, which of course is not how we think of how long we wash our hands. We usually think of it in seconds. So however you do that, you want to convert to minutes at the end. The easiest thing to do here is when we're doing the faucet audit, we will try our best to have students time each other and how long they wash their hands. And then you've got a nice representative sample and you can use that. You can see here that the way this is set up is for each group in each class period to enter how many kids are in their group and what the average time that they wash their hands for was. So that's there. So if you use those two things, the Excel spreadsheet will average out the numbers and give them to you and automatically input them here in these white boxes. If you don't want to do all of this and you just want to kind of make an estimate of an average, you can do that as well. You can just ask your kids to guess and they can come up with something. Well, we're supposed to wash our hands for 20 seconds. Okay, that's 1/3 of a minute. And you could talk about how many times they wash their hands and come up with something. So you can do that really simply, or you can investigate this more deeply. It is really fun. Another fun thing to do, I forgot to say about duration, is for kids to actually time other students surreptitiously in the bathroom. I've had teachers have a lot of fun with that, so I recommend it. All right, once you've done this, you're done and you actually can figure out the calculation. If you have a math teacher partner and you want to have them develop the equation with students, I would say stop here and make sure that they do that before you come back and actually celebrate the savings. It's a fun thing to do, and if you've got a math partner who would be interested, we've got lessons to support that, so please reach out. But if you are ready to just see your calculations, they will automatically input here and show us your total water use and water savings. So note that these are color coded, but water used for washing hands per year with our baseline condition that was out before we did any action, and that's the amount there at the bottom. And it's showing the equation here, so you can kind of see we're taking all of these numbers and multiplying them together. We've got the equation, and then we're here. This is without the aerators, and down here is with the new aerators.
That's a really big difference.
It's a big difference, right? Between 176,000 something and 54,000.
And that shows the students very quickly how they can actually be a part of citizen science almost, and really take charge of saving groundwater for their own community. So this is a really important step in the process of what we're trying to get across about groundwater conservation.
It's true. And we know from research that once students have taken one action like this, that they then feel more empowered to take further action. So this is a great time to really celebrate this and celebrate it with a graph, because everybody wants to see a comparison of how it was before and how it was after and how much we saved. So this is great. And then if students were really impressed by what aerators do at all, this shows how much we were using when we had our old aerators without the aerator and then with the new aerator. So there's two versions of the graph that you can look at together. And the really important thing is once you've completed this, that you get it back to us so we can record that that water savings and share it with the world and with the Arizona Department of Water Resources.
Our sponsor.
Our sponsor, who we really want to continue to sponsor us. So we want to keep telling them that we're saving water.
I really think it's a really good point that you brought up, the old aerator versus the new aerator, because then the kids can see changing technologies and how technologies have improved. And I think a lot of people don't know, like, oh, they updated the aerator, so I do need to change my aerator out. And Holly, you mentioned earlier in our conversation that aerator should be changed every how many years?
About every 2 years. And unfortunately, when we do that, you can imagine that the aerators get gunked up in mineral deposits. So they start restricting the flow even more. If you've ever used a faucet and like you turn it on and it's the needle spray and it's coming at you and it's like spraying everywhere, that's the mineral buildup. So getting those off and changing them out every couple of years is worth the effort. It doesn't necessarily conserve water, but it makes our things function better.
Oh, that's good to know about that spray, because I thought someone just had a weird faucet and thought, why do they put these on here?
No, I think usually it's when they're getting old.
Nice. Okay.
Yeah.
I like that point.
So the other thing to know is that when students get really excited about this, if they want to do it at home, 0.5 gallon per minute aerators are not necessarily the right technology for our home bathroom faucets, because we use them for things like brushing our teeth. And it's pretty hard to rinse the toothpaste off of your toothbrush with a 0.5 gallon per minute aerator. So we usually use 1.0 gallon per minute aerators in home situations. So that's just something, when students are excited about this, talking about what the right technology for the right purpose is another kind of learning point that we have out there.
That's another good point to bring up.
Yeah. All right. Thank you very much.
Thanks.